Assalamu alaikum. Welcome again to our next lesson, that is linear scale factor, area scale factor, and volume scale factor. So we finished our lesson. The part A was about drawing, part B is going to be just computation only. So tutaifanya. So consider the similar figures below. So question A, from the above figures, work out the linear scale factor and the area scale factor. Hapa kuna center of enlargement, hakuna lot. Now for us to work out the linear scale factor, then it is very easy. We normally take two distances that are similar, in which this one and this one are similar. So basically hii ndo hii hapa. So those two distances, you divide them. So utachukua ya image, so you take the distance of the image over distance of the object. Distance of the image is basically 9 meters over the distance of the object, which is 3 meters. You'll get the linear scale factor of 3. So question A tayari tushamaliza, so that is your linear scale factor. Now what is our area scale factor? Area scale factor is equal to linear scale factor squared. So once you get the linear scale factor, which is 3, you square it, 3 times 3 itakupa 9. And therefore that is our area scale factor. You can either take also wachukua 12 ukadivide na 4, bado itakupa 3 as your linear scale factor. Linear scale factor haina unit, so 15 divided by 5 also itakupa 3. And remember, area scale factor is linear scale factor squared. Now, what if we have a question like this? Hii ni linear scale factor. Consider the now kuna volume scale factor. Consider the cuboids below which are similar, which you have the image and the object. Work out the linear scale factor and volume scale factor. Now we said distance of the image, okay, over distance of the object. Distance ya image yako ni 4 divided by the object, which is 8. Umeona, it's tricky. Wachukua image over object. So 4 divided by 8 is going to give you a linear scale factor of a half. That is for question A. So this is linear scale factor. Volume scale factor, kama unataka kutafuta volume scale factor, then volume scale factor is just basically linear scale factor cubed. So the answer that you get, which is a half, you cube it, and cubing it means a half times a half times a half will give you 1 over 8. So that is your volume scale factor. So hii ndo volume scale factor yako. Again, let's write NB. NB is linear scale factor squared will give you area scale factor. The vice versa also is applicable. If you want to search for linear scale factor, utatafuta square root of area scale factor to give you linear scale factor. Linear scale factor cubed is equal to volume scale factor. But in case umepewa volume na umeambiwa utafute, umepewa volume scale factor na umeambiwa utafute area scale factor, utafute linear scale factor, then you just do cube root of volume scale factor to get linear scale factor. So those are two common rules that we need to know. The other thing that we need to know for us to get area scale factor, which is the ratio of areas. The ratio of areas. We normally do the same thing kama vile linear scale factor. You take the area of the image over area of the object, so itakupa ratio between two areas or area scale factor. And the same thing for us to get volume scale factor, ikiwa linear scale factor haiko, utatumia volume ya image over volume of the objects. Ni rahisi sana. Yeah. Now what if tumpewa kitu kama hii tena kwa mara ya pili? Work out the area scale factor of the similar figures shown below. Lazima ujue mambo na similarity pia and enlargement. Now this one ukiona triple na hapo pia una triple, so 25 is similar, so that both of the triangles are similar to each other, and therefore ya 25 ni hii hapa, kwa sababu kuna opposite ya hiyo triple angles. Okay, ni 2.25 na triple angle opposite yake hapa ni 12.5. So let's search for linear scale factor mwanzo kabla hujatafuta area scale factor. So linear scale factor ndo hiyo 25 over 12.5. 25 over 12.5, which will give you 2. So a linear scale factor is 2. You can also take this one as well. For now, we'll assume this one to be our image. This is object, kwa sababu hakuna pahali nimekuambia otherwise. Yeah, what we said, you can take over here, si lazima sasa take, usually I take the biggest over the smallest, but you can tend to take maybe the smallest over the biggest, up to you. 18 over 9 is also giving you 2. Now, area scale factor will be linear scale factor squared. So linear scale factor need to, if you square, it's going to be but ikiwa umeambiwa image ni gani, object ni gani, therefore be very specific on that. Now, these are two different questions. The two buckets shown below are similar. You have 1 liter bucket na kuna nyingine 125 cubic centimeter bucket. The diameter of the smaller bucket is 7.5 centimeter. Calculate the diameter of the larger bucket. Sasa hapo umepewa volume yako, volume ya hizo mbili. Now we know that 1 liter is just equal to 1000 cubic centimeter. You cannot compare, yani moja ikiwa liter nyingine cubic, lazima zote units ziwe sawa. So now we say the volume scale factor is equal to volume of the image. Let's say for now, the volume of the larger bucket over volume of the smaller. The volume of the larger is 1000 divided by the smaller, which is 125. So 1000 divided by 125 is going to give you 8. So that is the volume scale factor. Now for us to get a linear scale factor, because lazima tupate diameter ya larger bucket na tuko na diameter ya smaller bucket. So the ratio of two distances is usually linear scale factor. Na for us to get linear scale factor, tumesema lazima tupige cube root ya volume scale factor. So cube root ya 8 ni 2. So once we know that, let's say the answer to question 1 is this. So once we know the linear scale factor now, which is equal to 2, it becomes easier to know the diameter of the larger bucket. So linear scale factor is equal to the diameter of the larger over diameter of the smaller. The diameter of the larger bucket, how would you? But the diameter of the smaller one, let's say the diameter of the larger one is x, we don't know, it's unknown. But the diameter of the smaller one is actually 7.5. Now for us to get x, okay, because we already have our linear scale factor, for us to get x, we multiply 7.5 on this side and also multiply 7.5. And therefore x is equal to 2 times 7.5, which will give us 15 centimeter. So that is the volume, that's the diameter of the larger bucket. Hopefully is understood, diameter of the large bucket. Now let's go to question 2. Okay, so answer to question 2. Now let's read question 2. A bar of gold has a volume 165 cubic centimeter and a height of 4 centimeter. A similar bar of gold has a volume of 675.84 cubic centimeter. Calculate the height of the larger bar of gold. So volume scale factor hapa tena. So volume of the larger or volume of the smaller. So volume of the larger is basically 675.84 divided by volume of the smaller, which is 165. So let's see how much is our volume scale factor. So 675.84 divided by 165 is going to give us 4.096. Now we need to find linear scale factor, or at least to you the height of the larger bar. You can't get a height if you don't know the linear scale factor. So cube root ya volume scale factor tunasema itatupa linear scale factor. So cube root ya 4.096 is equal to 1.6. So there's another way of getting the height of the larger one simply by, and that is simply by multiplying linear scale factor to the height of the smaller, because we know the height of the larger one is 1.6 times bigger. Now, or the other way to fanya is that you take the linear scale factor is equal to the height of the larger one, which is x, over the smaller one, which is 4, kwa sababu we can have small volume, and that is why the height of the smaller the smaller height will be 4. So times 4 times 4, and therefore x is equal to 1.6 times 4 is going to be 6.4. 6.4 centimeter. Now another way nishaelezea, okay, because we know the height of the larger one, we don't know the height of the larger one, we know the height of the smaller one. We know the height of the larger one is 1.4 times 1.6 times bigger. Now 1.6 times bigger, because the ratio is 1.6, so yamaanisha ile kubwa ni 1.6 times bigger. So therefore we take 1.6 times the height of the smaller one. Okay, let me just write here, this is 1.6, but no, sorry, we know that the height of this is 4 centimeter. The height of the larger one is 1.6 times the smaller one, which will give you 6.4, which is, wait a minute, 1.6 times 4, 6.4 centimeter, and that is our answer. Now, the last part, study the figure below. A, B, O, or A prime, B prime. A prime or B prime is the image of A or B, and the enlargement to center O. Work out the area scale factor of the enlargement. Okay, so which is very easy to say so. Now, for us to work out the area scale factor, lazima tujue area of the two images. And for us to get the area of the two images, again, tutatumia linear scale factor. But I think it's very easy. It's not a hard. Okay, you can use two ways, but let me teach you most probably one way there. Okay, the first way is to use linear scale factor to square it, and you get area scale factor. So you need at least to know linear scale factor. Now this one is similar to this one. Just inside kama hii 6 centimeter, it's similar side ni 3. Kama hii ni 2.5, is similar side ni 5 centimeter, and that way. So for now, wacha tuchukue 6 na 3. So the distance of the larger one, which is 6, will give you linear scale factor. So 6 divided by 3 is going to give you 2. And as a result, obviously, for us to get area scale factor, linear scale factor squared is going to give you area scale factor. So if you check 2 squared, it's going to give you 4. That is the area scale factor. That is one way. The other way, I'll show you also. Okay. Now, the other way ni hivi. Mwanzo wafaa utafute area ya kila moja. So let's take the area of the image over area of the object, obviously. So we have this one. This is the image, which is a triangle, and triangle dot after v half times base times height. So let me just draw. So kuna image yako which looks like this, which hapa ni 5, hapa ni 5, hii ndo O A prime B prime, na hii ni 6. So ukicut into half after height, so hapa ni 3, hapa ni 3, and therefore your height is going to be 4 because of 3, 4, 5 Pythagoras theorem. So itakuwa half times base, which is 6, times the height, which is 4, and the area of the image itakuwa ni half times 6 times 4, that gives you 12 centimeter square. Now the area of the object, let's wacha tuichore pia hiyo object. Now object yako ni hii OAB, which is very small. So O hapa, A hapa, B hapa. This is 2.5 centimeter, 2.5 centimeter, and this is 3 centimeter. So area of the object, you have this as well. This is going to be 2.5, 2.5. No. Because of only 3, it's going to be 1.5, 1.5. And for us to get the height, basically what we do is you take c squared minus b squared, which is 2.5 squared minus 1.5 squared, then square root it to give you the height. Okay, so which will give you how much? On our calculator, 2.5 squared minus 1.5 squared, square root that gives you 2. So the height is 2. So utachukua pia a half times the base, which is 3. Remember, from here to here is 3 times height yako ni 2, which will give you 3 centimeters square. So the area of the object is 3 centimeters square. Now, for us to get linear scale factor, not a linear scale factor, for us to get area scale factor, you take the area of the image over the object. Now, in each area of the image in itself, divided by area of the object, 3, and it's going to give us an area scale factor of 4. That is the answer, and that is the end of the lesson. Again, don't forget to subscribe to the channel and also hit the like button. Say it to your friends. Assalamu alaikum.